In this lecture, we are going to look at extending our NLP example so that we can use a trained model to make predictions. A lot of people ask this question, and at a high level, you just need to follow the same steps that we did earlier to preprocess the text and call the model predict function. However, some students get overwhelmed with the amount of code, and so hopefully this lecture will clear up any confusion you may have had. Before we start, first recognize that we are in a separate VIP notebook, which you can find in the VIP Notebooks document. So to start, we're going to do a few things differently in this notebook to kind of extend what we discussed earlier. So if we scroll down to after the model is trained, you'll see that I also do a check for how many of our observations are actually spam. As you can see, it's not that many, only about 13%. This is an example of a dataset with imbalanced classes. So when we see accuracy in the high 90s, we might be concerned that our model is just predicting the majority class all the time. Next, we're going to look at the confusion matrix to see if our model is doing well on one class but not on the other. So I've pasted the same confusion matrix code from earlier in the course in this block. If we scroll down to the results, we can see that we actually do well on both classes. So this goes for the test set and with the train set. So it seems that even though the classes were imbalanced, this did not pose a problem for the model. Next, let's go on to making a prediction on a new test sentence. There are two ways I'm going to show you how to do this. The first way is closer to what we did earlier in this script, which I think is easier to understand. That is, we want to start with a CSV file containing our data. So first I have a snippet of code here that shows you how to sample from the data frame, but only for the rows where the label is spam. In the next block, I assign this to a variable called small sample, and then I write this to a CSV file called sampletest.csv. Note that the only thing I'm writing to this file is the sentences themselves, not any of the other columns. So in the first line, I say open sampletest.csv in write mode. In the next line, I write the header row, which is just the string data. Then I do a loop through the small sample data frame using the iterRows function. Inside the loop, I select the data column from the row and then write that to the file along with a new line. Next, we use the cat command to confirm that our CSV has been written properly. As you can see, it contains only the data column with the corresponding spam sentences. The next step is to create a tabular dataset from our CSV. This is almost the same as the code from earlier, but notice that in the fields argument, I only have one field, which is data. I also pass in the text field object that we created earlier, since this contains all of the information about tokenization and the vocabulary and so forth from the train set. Next, I create an iterator object from the dataset object, which is similar to what we did earlier when we called iterator.splits. As you can see, it takes in almost the same arguments: a dataset, a batch size, a sort key, and a device. But you'll notice that before, the splits function took in multiple datasets, whereas this takes in only a single dataset. Now you might wonder, how did I figure out such an object existed? Well, guys, you have to read the documentation. All the information is there. In the next block, we loop through our sample iterator. So this is the moment of truth where we get to find out whether this will work or not. As you can see, it's slightly different from what we had earlier. In the previous loops, we got back the data directly as tensors. But it seems that, in this loop, the data is returned as a batch object. We can access the data by calling inputs.data. Unfortunately, the API for the iterator object versus iterator.splits is inconsistent. Well, you just have to observe what's going on and make the necessary changes. Nobody said you wouldn't have to put in some effort. As you can see, our predictions come out just fine. Now, your next question might be, what if I have just a single sentence and I don't want to write it to a CSV? In this case, we can still make use of the torch text documentation to figure out what to do. So we'll start with a sentence from the spam set, and I'll assign this to a variable called single sentence. The next step is to use our text field object and call the preprocess function on this single sentence. Here I'm just printing out the result to confirm that it does the right thing. As you can see, this only does the tokenization part, but it does not map the tokens to integers. The next step is to call the numericalize function, which converts the above tokenized sentence into a sequence of integers. Unfortunately, the API is a bit inconsistent here again, since this accepts a list of tokenized sentences rather than just a single tokenized sentence. Finally, the last step is just to put these all together and then use our model to get a prediction. So in the last block of code, we call text.preprocess to convert our sentence into tokens. Next, we call numericalize to convert our tokens into a sequence of word indexes. Lastly, we call our model, and we pass in the sequence of word indexes after moving the input tensor to the GPU. As a final side note for this lecture, you may want to check out another notebook I created, which uses the Keras API to preprocess the text. It might surprise you that this is possible, but in fact, since the Keras API just gives you back a NumPy array, there's no mixture of Keras code with PyTorch code. I found that this was advantageous in a few ways, namely that it achieves better accuracy, perhaps due to smarter default tokenization, and the API is easier to work with and more consistent than Torch text. You can find this notebook along with the rest of the VIP notebooks in the extra section.